Okay, class, we're going to start off just by proving that tangent equals sine over cosine and that secant equals 1 over cosine. So if you look at this triangle here, we have a small triangle from the unit circle. I'll draw that in, this green triangle. And we know that in the unit circle, this side is cosine theta, this side is sine theta, and this side is 1. We also have this big triangle with a line drawn tangent to the circle. That's why that line is called tangent. And the other line is defined as secant. So here's what I have. I have a big triangle, and I have this side is tangent theta. And then I'm not going to touch the secant part yet because I'm not going to prove that. But you guys should note, if you look at the big red triangle, the bottom is a length of 1 because it's the radius of the circle, right? You guys see from here to here. If I look at the green triangle, I know this is cosine theta, this is sine theta, and then the hypotenuse of the green triangle is also 1. So since they're both right triangles, and then they also both have the same second angle theta, they are similar. If you remember from geometry, angle proves similarity. So therefore, we can do a similarity. We could set up a proportion. So I want to solve for tangent. So I know tangent of theta over 1 is equal to the corresponding side, sine theta over cosine theta. And sure enough, I just proved what I needed to prove, because tan theta over 1 is tan theta. Okay. We can do the same thing down here with secant. We know this is 1. We know this is secant theta. And we still know that this triangle is cosine theta, sine theta, and 1. So if I want to set up a ratio, I can say secant theta over 1 equals, the thing that corresponds to it is 1 over cosine theta. So sure enough, secant is just the reciprocal of cosine. So we just use similar triangles to prove that, but you won't have to memorize, you'll just have to know what it is. You don't have to know how to prove it, okay? I just wanted to show you. So here's what you do need to know. You need to know these things. So again, in a normal point, sine is equal to y over r, cosine equals x over r, and tangent equals y over x. Here's how you remember the reciprocal functions. Sine goes with cosecant. So c and s go together, c and s go together. The two s's do not go together, the two c's do not go together. So sine goes with cosecant, which means that cosecant is the radius over y. It's just the flip of sine. Secant is 1 over cosine, or the flip of it, which is r over x. And cotangent is x over y. Okay, so those are the 6 trig functions we're going to be working with. So if you know sine, cosine, tangent, you know the other 3. You just flip them around. So let's do some problems with this. First thing you have to figure out is what quadrants you're in. Cosine, or x, is positive in quadrants 1 and 4. But tangent is negative in quadrant 4 and in quadrant 2. So in order for both these things to be true, we have to be in quadrant 4. So I draw my triangle in quadrant 4. I put my values on. I know the cosine is equal to 4 over 5. Cosine is adjacent over hypotenuse. You guys should know, well, you could use Pythagorean theorem if you need to, but you should know this triple. It's something 4, 5. It's a 3. Be careful though. The sine, we're in quadrant 4, so this has to be negative. And now you can start doing all the pieces. So we know cosine is 4/5, sine is negative 3/5, and tangent is negative 3/4. Okay. So secant is the flip of cosine. So cosine I was given as 4/5. That means secant has to be 5/4. Cotangent's the flip of tangent. So since tangent's negative 3/4, this is negative 4/3. And cosecant is the flip of sine, or the reciprocal. So we get negative 5/3. So now we have all the trig functions based on that triangle. Okay, let's do a couple more. Secant is nice. If they give you one like secant first, just rewrite it as the other one. So this is cosine of theta equals 5/13. So right away we know that this is 5 over 13. Okay. And again, it's positive, so we're in 1 and 4. So if cosecant is positive, that means sine is positive. And sine is positive in 1 and 2. So that means we're in quadrant 1. which is kind of nice because that's where everything's positive. We know the cosine is 5 over 13. And if you use Pythagorean theorem, you'll get a 12 here. And again, it's positive. Everything's positive in 1. So the sine is opposite over hypotenuse. Tangent is opposite over adjacent. And now we do the other two. Cosecant, you flip sine, we get 13 over 12. Cotangent, you flip tangent, you get 5 over 12. Okay? Last one. Tangent's negative, and that happens in 2 and 4. Cosine's negative in 2 and 3. So we're in quadrant 2. So there's my triangle in quadrant 2. Tangent is negative 11, or root 11 over 3. Put the negative on the correct spot. Does the negative go with the root 11 or with the 3? Hopefully you guys see that since it's the x is negative, it goes there. Pythagorean theorem, root 11 squared plus 3 squared equals h squared. 11 plus 9 equals h squared. So h equals root 20, which is 2 root 5. Okay, so now we can start filling out this thing. Sine is opposite root 11 over 2 root 5. We have to rationalize by multiplying by root 11, or root 5. So sine is root 55 over 5 times 2 is 10. Cosine is negative 3 over 2 root 5. Again, we need to multiply by root 5. So it's negative 3 root 5 over 10. And now we can start flipping these, or just going the opposite way on the triangle. Secant is the same as cosine, but the opposite, so it's hypotenuse over that. It's better to do it that way than to flip cosine, because if you flip cosine, you're going to get a root on the bottom again. So instead, just think about flipping it on the triangle. Cosine started off as negative 3 over 2 root 5, so that means secant should be 2 root 5 over negative 3. Cotangent was a root 11 over, or tangent's negative root 11 over 3. This one we do have to flip and multiply by root 11. Negative 3 root 11 over 11. And cosecant's the flip of sine, so sine was that over that, so cosecant is 2 root 5 over root 11, multiplied by root 11s. And you get 2 root 55 over 11 for cosecant. Okay, so that is what we're going to do today, and that is the lesson.